A number is selected from the first 10 natural numbers. Okay, so we're picking numbers from 1 to 10. Consider the events m for prime. I guess they didn't want to use p for prime because p means probability. And n for an odd number is chosen. Now, this is sticky because it's debatable whether 1 is a prime number or not. I think in this book they say that 1 is not a prime number, and so their list of primes goes 2, 3, 5, 7, and not 8, 9, 10. So their primes would be 2, 3, 5, and 7. If you think 1 is a prime number, I agree with you, but I don't think this book does, so I'm going to go with this. I think this will match solutions that they post elsewhere and other examples that they might do about primes. And an odd number is chosen. That's pretty unambiguous. 1, 3, 5, 7, and 9 are the choices there. So our sample space, our overall sample space is all the things that can happen when you pick a number from 1 to 10, which is not too complicated. And then the outcomes for m, got it. N, got it. What's m and n? This means a number that is prime and odd. So what numbers are there that are on the primes list and also on the odd list? 3 is on both lists, 5 is on both lists, and 7 is on both lists. Those are the numbers that are prime and also odd. And for m or n, that would be the numbers that are either prime or odd. So now we have to do like the overlap, or not the overlap, the combination of these two lists. That would give you 1 and 2. 3 occurs twice, which is fine. Not 4, 5, not 6, 7, not 8, and 9, and not 10. So there's all the numbers that are either prime or odd, or in some cases both. State the probabilities of the events, blah, 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 blah. Okay. Well, event m happens 4 times out of 10. And of course we expect you to reduce that. Event n happens 1, 2, 3, 4, 5 times out of 10. Reduce it. M and n happens 3 times out of 10. Can't be reduced. And m or n happens 1, 2, 3, 4, 5, 6 times out of 10, which is 3 times out of 5. So there's all our probabilities. Determine the probability that a prime is chosen given that an odd number is chosen using the appropriate formula. Okay, we could work this out just by looking at our numbers, but they tell us not to. The formula for this, they call it the multiplication law for dependent events, says the probability of m given n. Oh, sorry. I always want to start it that way, and that's not how they have it go. As it's given, it's the probability of m and n, they start with the and version, is the probability of n times the probability of m given n. Why did I put n here? Because this event is the one that goes in the given spot, and that's what they want us to find. If they were asking for nm, I would have probability of m, and then these would be flipped around. So you have to pay attention to their order. The and, it doesn't matter how you change the order, it means the same thing. But over on the right side, whatever event you say first is now a given. Right? We're saying n happens, and then we go over to this other event and say, okay, n has happened, what's the chance of u happening now? They want m given n, so I had to start with the n happening. All right, so if we clean this up, we get the probability of m given n is the probability of m and n divided by the probability of just n. And fortunately, we have all these things. M and n is 3/10. And the probability of just n is 1/2. So that's 3/10 times reciprocal, 2/1. That cleans up to 3/5. So 3/5 is the probability of m given n. In other words, if I tell you a number is odd, the chance that it's prime is 3 out of 5. Now, what's next? Aidan said a quicker method of determining the answer in C, what we just did, m given n, would be to look at the number of odd numbers in the sample space and count how many of those were prime. So, let's try that out. If we have odd numbers in our sample space, meaning that, and that, and that, and that, and that, there are 5 of those numbers. How many of them are prime? 1 doesn't count, for reasons I don't want to get into. Contact your teacher if you're curious about this, and they can explain it to you. But it's kind of a cheat that linear algebra people use, and it takes a while to get into it. 3 and 5 and 7 are prime, and then 9 is not prime because it's factorable. So, yeah, we could have gone through the sample space and said, okay, here's all the odd numbers. How many of you are prime? 3 of you are prime. That means if you get an odd number, there's a 3 in 5 chance that it'll be a prime number. So, yeah, nothing wrong with this. The advantage of the formula is that the formula works even if these are very complicated or very big. If there are millions of entries, you don't want to go counting through them. And also, sometimes you don't have the sample space, you just have the probabilities. So you want to be able to work problems like this. But yeah, if you have the sample space, this is a perfectly reasonable way to go. And now they want to determine the probability that an odd number is chosen given that a prime number is chosen. So they're asking for the probability of odd given prime. Opposite of what we just found. So our setup's going to be, like before, the probability of m and n equals, they want m to be a given. So we're going to say, okay, first of all, what's the chance of m happening? And then probability of, hey n, what's your chance of happening if we guarantee that m just happened? We solve for that, and we get the probability of n pipe m is the probability of m and n, which we know is 3/10, over the probability of just m, which, let's see here, where did we leave that? The probability of just m is 2/5. So 3/10 divided by 2/5 is like 3/10 times 5/2, which is like 15/20, which is like 3/4. So if you've picked an odd number, there's a 3 in 4 chance that it's also a prime number. Let's see if that checks out. We'll use the Aidan method and actually go to our sample space. If you've picked a prime number, here we are. If you've picked one of these prime numbers, there they are, what's the chance that it's odd? Well, that's odd, that's odd, that's odd, so yeah. If you're just looking at the prime numbers, there's a 3 in 4 chance that you're looking at an odd number as well.